Okay, so in this particular lesson, we're going to talk about um, angles, uh, degrees, radians, all kinds of great stuff. So let's just get started. Okay, and so first thing we're going to talk about is positive angles go counterclockwise and negative angles go clockwise. So that's kind of a little counterintuitive to what you see. Another thing we talk about is standard position. So angle in standard position, there are some parts of an angle. Standard position means that the vertex is at 0, 0, and the initial side of the angle is along the x-axis, and the terminal, think a terminal means it comes to an end, is out this way. So you can see here that we have the initial side and the terminal side of a positive rotating angle. This angle right here, theta, is 135 degrees. And so you can see that if we can spin a whole circle is 360, so 0, 90, 180, 270. If you go the other way, if you go clockwise, this guy right here, this is our angle in standard position. Why? Because the vertex is at 0, 0, right? Its terminal side is over here. It goes negative 45, but it's kind of the same idea. Very simple, very, very easy to talk about. Now, there are some things that we need to talk about, discuss. Besides degree, there's another one called radian. Radian is used to measure arc length. Now, if you think of this, you know circumference as being 2 pi r, right? Well, all the way around the circle is 360 degrees. All the way around the circle is 360 degrees. If I call that equal to 2 pi r. Well, if I have a circle and I just kind of say that my radius is 1, like over here, see how this circle right here has a radius of 1, then now I have 360 degrees is equal to 2 pi, and we'll call this radians, because radian is a length of the arc. So if I solve this for radian, I have 360 degree over 2 pi is equal to radian, which realistically has a conversion 306, or excuse me, 180 over pi is equal to radian. 180 over pi is equal to 1 radian. Or you could say 1 degree is equal to pi over radian. So realistically on your unit circle, 0 is 360 degrees, 90 degrees, well, halfway around the circle is 180, so halfway around the full circle is 2 pi, so it's pi. So halfway, a quarter of that is pi over 2, 3 halves pi, and then this is obviously 2 pi. So when you go around it, you just kind of need to know your conversion. So let's try some stuff here. So let's convert from radians to degrees. So you have pi times 9. Well, what I'm going to do is I'm going to say, okay, that's pi over 9. That's radians. So I'm going to go times 180 over pi. And you can see pi goes away. And now you have 180 over 9. And then that kind of reduces to, that's 1. So that's equal to 20 degrees. Negative 3 pi over 5. And what I'm going to do is I'm going to go ahead and multiply that by 180 over pi. You can see that this pi goes away. It's mumbo jumbo. The 5 goes into the 180. Let's see. 5 goes into it one time. And then that goes into it, oh, I don't know, 36 times maybe, something like that. So then what does that become? That becomes, what does that become? Is that 36? So then that becomes negative 108 degrees or something like that, right? Makes sense. And then the last one, 5 pi. Well, 5 pi, I'm just going to go ahead and multiply 180 over pi. Pi goes away. They cancel out. 5 times 180, well, that's a 900 degrees. Easy enough. Let's go the other way. What if you have to go from degrees to radians? Well, to go from degrees to radians, you're going to use what's called the reciprocal rate. So I'm going to multiply this by pi over 180. 0, 0, and then it's 15 pi over 18, which reduces to 5 pi over 6 radians. Negative 330, I'm going to multiply by pi over 180. 0 goes away. I get negative 33 pi over 18, which reduces to negative 11 pi over 6. 540 degrees. Well, I'm going to multiply this by pi over 180. Zeros cancel out. You get 54 pi over 18, which reduces to, how about 3 pi? Right? Simple. Cool. All right. Now, let's talk about this. Find an angle measures from each graph. So on this guy, so this obviously is a positive degree angle. Now, what we can think about is it gives us this opening of 60, right? It gives us this opening of 60. So realistically, a full circle is 300. So this angle is 300 degrees, if that makes sense. Looking at the next one, this one is going clockwise, so it's negative. And so what I want to do, since it's negative, it's I'm going to take, I got to think, okay, well, from here to here is 115. Then from here to here is 90. So what's 115 plus 90? 115 plus 90, that's... what is that, 215 or something like that? So how many more do I need to make 360? That's 155. But since it goes in the negative direction, it's 155 degrees. Right? Makes sense. This guy right here, this one's kind of crazy, but all you got to do is think of, all right, it starts here. That's 360. That's 360 more. That's 720 plus another 180, that's 900. Speaking of 900, Tony Hawk did one at 48 years old this summer. Yep, on a skateboard. All right, so what you want to do here is it wants you to draw the angle in standard position. State the quadrant in which the terminal side is located. So standard position, you're going to have an x and a y-axis. Standard position means that its vertex is at 0, 0, negative 110. Well, negative 110, it's going to start here, right? But it's going to open this way. This is 90. It's about 110 right there. There's a negative 110 degrees. And so what quadrant is that in? If you don't know, this is 1, this is 2, this is 3, and this is 4. So it's in quadrant. The terminal side is in quadrant 3. 530 degrees. All right, draw your x and your y-axis. 530 goes clockwise. We know we go 360 degrees gets me here. 360 degrees gets me here. And another 180 would be 540. So I'm going to come this way. Something like that. Something like that. This is in the second quadrant. All right. 3,400. Oh, that's crazy. Well, what you can think about is 3,400. I guess I would say how many times does it go around 360? So 3,400 is a lot. So 3,400, I don't know, something like this. I just know that it's over in the second quadrant. 3 pi. Well, we got to remember we talked about earlier. This is 0. This is pi. This is also 2 pi. So 3 pi is right here. That's 3 pi. 2 pi plus 1 pi is 3 pi. You're not in a quadrant. You're on a boundary line. Weird. Couple more. 4 pi over 3. 4 pi over 3. Well, 4 pi over 3, if we think about our 0, pi over 2, pi, 3 pi over 2, 2 pi. 4 pi over 3 is a little bit bigger than 1 pi, right? Because 3 pi over 3 is 1 pi, so you're probably right in here. You're in quadrant number 3. Negative 7 pi over 3, you're going clockwise. That looks like it's a little bit past 2 pi. A little bit past 2 pi. So I'm going to go this way, go a little bit past 2 pi. I'm right here. And that is in quadrant 4. Does that make sense? Seems pretty easy enough. Let's get to the good stuff. All right, so what we're going to talk about here is the arc length of a circle. Now, depending on whether the angle is given in radians or degrees, depends on the formula. The arc length you can think of as the length is equal to theta times the radius. If it is given you in radians, if it's in degrees, just convert it to pi over 180 instead of radians. Another way to think about it is this. Basically, it's just part divided by the whole times the circumference. Well, the circumference of a circle is 2 pi r. All right. So let's try this on a problem. All right. Oh, sorry. In area, sector area. Sector area, you know that the area of a circle is pi r squared, so use the same idea. Part over whole times area. Okay? So now we'll try a couple problems. So here's the first one. It says find the arc length and sector area of the following. So we have 2 pi over 3 is that angle, and then we also have 14 centimeters is the radius. So to get the length, if you do length equals part over the whole times 2 pi. If we do the part over the whole times 2 pi, what part do we have? Well, we have 2 pi over 3, and that's all over 2 pi, and we're going to multiply this by 2 pi times 14. We multiply that by 2 pi times 14. Now, this is 2 pi over 3 divided by 2 pi over 1 times 28 pi. So then this flips it, so you got 2 pi over 3 times 1 over 2 pi times 28 pi. 2 pi's go away. You're left with 28 pi over 3 centimeters. Makes sense? Now, if I want to find the area, you do the exact same thing. The area is the part over the whole times pi r squared. So in this case, it goes back to 2 pi over 3 divided by 2 pi times 14 squared. Now, you saw that the 2 pi, this becomes 2 pi over 3 times 1 over 2 pi times 14 squared, I think is 196. This is 196 pi. So then 2 pi goes away. You get 196 pi over 3 squared centimeters in area. Seems pretty easy. What I'd like you to do now is I would like you to try to do this problem. Bring me your answers in class tomorrow, and then we'll be good to go. Remember, you want to find the arc length and sector. The thing I would tell you is now we are in degrees and not radians. Okay? Hopefully that makes sense. I look forward to seeing you in class tomorrow, and may the force be with you.